So these postulates are basically mathematical formulation to understand quantum mechanical approach to system. And obviously we have seen that wave particle duality as well as randomness is a part of quantum mechanical outcome. And so we have to formulate our mathematics such that it can just fulfill these two stories together. And a lot of myth about quantum mechanics is that if you are talking about quantum mechanics, you are just neglecting classical mechanics. That is nothing to do. It's all about your observation, which type of observation you are going to see. And some observation can be explained by classical mechanics. At the same time, some observation cannot be explained by classical mechanics, and that can be explained by quantum mechanics. A lot of people have also in a dilemma that whether particle is quantum or particle is classical. So there is nothing called particle, classical particle, quantum mechanical particle from my point of view. It's all about your approach to understand the observation. So when quantum mechanical formulation is suitable to your observation, that will just tell you, and they are just in the resonance of your observation, then obviously we will use quantum mechanical theory or quantum mechanical formulation. And we have also seen that some point classical mechanics is not working, so why we are using quantum mechanics. But it doesn't mean that classical mechanics is fail actually. It's all about that classical mechanics has not enough tool to explain this particular observation, and so why we have taken the quantum mechanical tool. So how you should understand the system, how you should approach the observation of a system, it will all deal in a postulates of quantum mechanics. So mainly we will discuss 5 postulates, and these 5 postulates are very important, and we can use these postulates to understand the observation whatever present in a nature, mainly at the microscopic level, at the microscopic point of view. Quantum mechanics is very well suited, and you can easily use these particular quantum mechanical techniques. So let's try to straightforward go for postulates 1. So every postulate has its name, and according to that name, we have to define something, we have to just discuss something, and hence they are postulates. They are not supposed to be derivation, or you cannot derive a lot of thing in the postulates. You have to just assume they are one kind of assumption, that on the basis of that assumption, you can discuss different type of mathematical formulation in quantum mechanics. So let's start with the postulates 1. This is very strong postulates, very smart postulates, and you will see how these postulates will take care of both randomness as well as wave particle duality. So let's try to go for first postulates, and that is very interestingly named as state of quantum mechanical system. So before going to state of classical system, before going to state of quantum mechanical system, we have to talk about the state of classical system. So what is the state of classical system? The state of classical system is nothing, position and its conjugate momentum. These are the state of classical system. Classical state. And we can always try to evolve this classic. We can just try to see how this classical state is going to evolve with the help of Newton's law. You can approach Newton's law in a different way. You can directly write Newton's law. You can approach Newton's law with the Hamiltonian principle. You can approach Newton's law from the Lagrangian principle. So there are n number of ways that you can approach Newton's law. But ultimately, we have to solve the differential equation, and that differential equation is nothing but second order differential equation, and this is md square x dt square is equal to some force fx. And if you are able to solve this differential equation, hence this is second order differential equation, so you need two initial condition to solve completely to this particular differential equation, and these two, one initial condition will be for the position, and the another initial condition with the for the velocity or momentum. You can easily solve this particular thing completely. But unfortunately, in a quantum mechanical treatment, Newton's law doesn't hold. It is very difficult to find position and momentum simultaneously, because there is uncertainty into position and momentum. We have uncertainty principle, and this uncertainty principle is given by delta x into delta px, which is greater than h cut by 2, and hence there is uncertainty in position and momentum. That means you cannot measure precisely position as well as momentum simultaneously. At the same point of time, you cannot measure position as well as you cannot measure momentum. So hence, if you are not measure position and momentum simultaneously, then obviously it is very difficult to write this particular equation of motion. And so why we are not going in that way to understand our system. So what will be next? So we have to try to understand system. So why we need to define a quantum mechanical state of a system. And what is this quantum mechanical state of a system? So quantum mechanical state of a system is defined by a kit. So there is a quantum mechanical state kit, and this kit is associated to Hilbert space. This kit is associated to Hilbert space, corresponds to system of a particle. Correspond to system. So there is a state psi, and that state is associated to the Hilbert space, corresponds to your system. So every system has associated Hilbert space, and this psi belongs to that particular Hilbert space. So this is definition of state psi. Now, this state psi will be function of, and this can be written as a functional form, and this can be function of dynamical variable x or generalized coordinate x or generalized coordinate q. If we are talking about one-dimensional system, then it will be obviously related to generalized coordinate or dynamical variable x. Suppose it belongs to two-dimensional system, then this psi will function of what? X and y. If we want to represent my system in a Cartesian coordinate, but if we want to represent my system in a polar coordinate, due to basically understanding of symmetry, due to the fact which known to the symmetry, then obviously we can use this dynamical variable as r and theta. So similarly, you can use any dynamical variable which will be actually related to generalized coordinate of a system. So obviously, this psi is actually function of your dynamical variable. So x is here some dynamical variable. X is here some dynamical variable. So this state of a system is basically, or state of a quantum mechanical system I am talking about. This belongs to basically Hilbert space. Okay, I can write this thing in another way, that belongs to Hilbert space, and which is associated to the system, which is associated, that is much better in English, associated to system. So this psi belongs to Hilbert space that associated to system. For example, harmonic oscillator. For the harmonic oscillator, there is a associated Hilbert space, and your state psi belongs to that particular Hilbert space. Suppose you have particle which is rotating in a ring, then obviously your quantum mechanical state is associated to that Hilbert space, that will or that psi belongs to that Hilbert space which is associated to the particle which is moving on a circumference of ring. So first you have to, so you can always see, first you have to classically define your system. Once you will classically define the system, then only you can define the dynamical variable, which is very popularly known as generalized coordinate. So your dynamical variable is equivalent to mainly your generalized coordinate. And so you have to first define your system classically. And once you are going to define the system classically, then only you can define the quantum mechanical state of a system. And that is part of abstract space. And they are, and obviously, but even if they are from the abstract space, they are actually function of the dynamical variable, which is actually real thing. Now everyone is comfortable right now? समझ में आ रहा है?
Yes, sir.
Okay. Now, so this is the definition of a state. But what is your first postulates? The first postulates is very interesting. If psi1 is a state of a system, psi2 is also a state of a system. There may be more than one number of a state. So psi2 is also a state of a system. Similarly, you have psi n, which is also a state of a system. Then we can create any state. We can create any state which can be actually C1, psi1, C2, psi2, up to Cn, psi n. So we can create any state which will actually superposition of different state. And obviously, we have seen this is nothing but the property of Hilbert space, isn't it? Hannah?
Yes, sir.
This is nothing but the property of Hilbert space. What is this particular thing? This is very famously known as closure relation, isn't it? If one vector belongs to one particular Hilbert space, another vector belongs to same Hilbert space, third vector belongs to same Hilbert space, then you can take any superposition and that belongs to the same Hilbert space. So superposition of state is also a state of a system. Same like electric field. The superposition of electric field is also electric field. The superposition of wave is also wave. So here we are just talking about the superposition principle. So this is a very strong statement. This is very strong statement, and we are including the principle of superposition. So if we are including the principle of superposition, Somehow we are just introducing the wave nature of a particle, isn't it? Somehow we just want to see our wave nature, because if you are doing superposition, this will have some inherent property of the wave. And here we will tell it wave function, because we will find that we will use this particular term wave function. Why we are using this term wave function, that will we come to the postulates, last postulates, that is when we will solve the Schrodinger wave equation. That is very important thing. But in general, if you have n number of kit, and which is actually a state of a system, then you can create a new state by the superposition of this kit. And obviously, how you are making it superposition, that will depends on the choice of your system and choice of your final conclusion. Okay, so this is all about something inherent wave nature of particle we are just trying to inbuild in this particular postulates. यहां तक clear है?
Yes, sir.
Everyone?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now, if you have this particular state, and I can represent this state as a function also, don't worry. You can represent it in the kit, you can represent it as a function, you can represent it as a matrices, different type of way you can represent your state of a system. Quantum mechanics give you leverages that you can use all different type of mathematics, depends on suitability of a system. So this is one of the big thing for the quantum mechanics. You cannot say only function is my state. You cannot say only vector or matrices is my state. It will depend how you want to represent your state of a system. So now, suppose this is my state of a system, psi is equal to psi x, and hence this belongs to Hilbert space. That means it should be a square integrable, isn't it? Every function belongs to Hilbert space must be what? Square integrable. And if it is a square integrable, it is 100% normalizable. You can normalize it. So what will happen? So if the function is normalized, so this is very interesting. If mod square dx and minus infinity to plus infinity is equal to 1, that means psi x is normalized. Psi x is normalized. So now, if psi x is normalized, then what you can do? Then here is the most important definition for the quantum mechanics. Then mod psi square is identified as probability density. Then mod psi square is identified as probability density. And which type of probability density? It will just tell you, and this term mod psi square dx will tell you the probability to find the particle, between x to x plus dx. Between x to x plus dx. So this is your probability that your particle belongs to x plus dx. So what will be probability that your particle is between x to x plus dx? You can easily find there. Why? Because this is nothing identical, and this mod psi square is nothing but psi star psi, and this will be your probability density. Okay, so this is your probability density. So whenever you are talking about probability density, then obviously you have to represent your state of a system as a functional form, because it is very difficult to write the state of a system in a form of kit or in form of matrix. So you have to be little bit careful when you are writing the probability density. When you are writing the probability density, you have to write this thing as a functional form. What are the functional form of your kit? And it will depends which type of problem you are just trying to solve it. Right now, everyone is comfortable?
Yes, sir.
Clear है ये? Everyone? Okay. चलिए. So this is our first postulates, very strong postulates and very smart postulates we are just talking about. So once you have this particular probability density, then you can easily say what will be probability that your particle is between x to x plus dx. Because in a quantum mechanical approach, your particle can be extended from minus infinity to plus infinity. You cannot see, or you cannot make sure that your particle is localized. Your particle can be anywhere between minus infinity to plus infinity. It's a very weird thing, but yes, in this way, quantum mechanics works. Now, it's okay. And once you are getting this particular probability density, then we can easily find average value of x. And this x is nothing but the position. Are you getting my point? This x is not any random variable. This x is nothing but the position. So what is average value of x? Last class में बताया था ना? X rho x dx. You will just go from minus infinity to plus infinity, and obviously you have to go for dx, and that value is again minus infinity to plus infinity. So in term of wave function, how you will write it? You will just go from minus infinity to plus infinity x. What will be rho x? That will be mod psi square x dx, and this will be again minus infinity to plus infinity mod psi square dx. Obviously, if it is normalized, then this must be what? 1. So अगर normalize है तो इसको लेने की जरूरत नहीं है. Otherwise, you can easily calculate what is the average value of x. And once you are getting to calculate average value of x, you can easily write average value of x square, and this is nothing but minus infinity to plus infinity x rho x dx, and you have minus
Sir, x
infinity.
square.
Sorry, x square. Thank you. So that will be dx. And obviously, this can be written as a density function. How you will, this rho x can be written as what? Minus infinity to plus infinity x square mod x square dx by minus infinity to plus infinity mod psi square dx. So this is basically once you define probability density. And what is x? X is just a position, because you are just this rho x or mod psi square, it will be the probability density, and mod psi square dx will just tell you what will be the probability such that particle will be in the position x to x plus dx. This is all about your postulates 1. Okay, and yes, you can find delta x also. And what will be this delta x? Delta x is equal to nothing but expectation value of x square minus expectation value x whole square. This is all about your probability density and first postulate. So first postulate is very strong. It will tell you all about the wave nature of particle. It will also tell you about the particle nature, because we are just talking about what will be probability such that particle will be between x to x plus dx. So once you have superposition, as well as mod psi square will tell you where is the particle is going to be most likely or less likely, depends on which type of distribution is there. And so this postulates is going to combine each other. Everyone is comfortable?
Yes, sir.
Okay. So there is lot of myth that suppose I am giving you psi is equal to, let's say, Cn pi n plus Cm pi m. Okay. So suppose this is your psi and you have phi m and phi n is equal to delta nm. Okay. Now, is that mod psi square is equal to psi and psi? Is that mod psi square is equal to psi and psi?
Yes, sir.
No,
No, sir.
no, this is wrong. Look at why this is wrong. First, let's try to go for psi psi. What is psi psi? I can go for mod Cn square plus mod Cm square. Everyone is comfortable?
Yes, sir.
Everyone, हम लोगों ने इस तरह के प्रॉब्लम कर रखे हैं. They are written in an orthonormal basis. Though this psi psi is mod Cn square and mod Cm square. Now, this is number or function?
Number.
Number. This is just a number. Good. So this is just a number. Now, and what is probability density? This is function or number?
Function.
Function. So how your function will equal to number?
Void.
नहीं होगा ना?
Void.
Sorry?
Sir, not possible.
Not possible. Exactly not possible. So, whenever the probability density, the concept of probability density come into picture, what you will do? You will just rewrite this equation something like psi is equal to Cn pi n plus Cm pi m. So what will be psi star? What will be psi star? This is something Cn star pi n star plus Cm star pi m star, isn't it? And what will happen to psi star psi? How many terms will be there?
So 4 terms will be there.
4 terms. So when you are just going to write psi star psi. Is that visible? Yeah, visible. So I can use this space. So when I will write psi star psi, then how many term is there? First term, that is mod Cn square, mod phi n square. Second term is all about mod Cm square, mod phi m square, plus cross term, the first cross term is equal to Cn star Cm phi n star phi m plus next cross term is this one, Cm star Cn phi m star phi n. Everyone is comfortable?
Yes, sir.
Okay. And now, can I say if this is my sum number and this will be complex conjugate of this number? If this is u, then this will be u star?
Yes, sir.
Yes. So then this can be mod Cn square, mod phi n square plus mod cm square mod phi m square plus 2 times real part of cn star cm phi n star phi m. Isn't it? You have u plus u star. Suppose this is some complex number or complex function. You are just going to add with this complex conjugate. Then you will get what? 2 times real part of u. Isn't it?
सर नीचे का नहीं दिख रहा.
नीचे का नहीं दिख रहा. Just a minute. Now it's clear? है ना? आप नंबर से भी इसको देख सकते हो. x plus iy. Suppose z is equal to x plus iy. What is z bar? X minus iy. When you will add it, then what will happen? Z plus z bar is 2 times real part of x. Isn't it? होगा ना?
Yes, sir.
Now this is your psi star psi. Now this is your probability density. Are you getting my point? This is number or function?
Function.
This is
Function.
function. Now when this thing is equivalent to this one, ये दोनों कब equivalent होगा? Just tell me. Just tell me. When
And
these
there
two
is-
things are going to equivalent to each other, बहुत ज्यादा बच्चे गलती करते हैं इस पूरे के पूरे चीज को. Just tell me.
m equal to n.
Huh? No, no. When these two things is going to equivalent, when you are just going to make this integration, isn't it? This is nothing but the scalar product. Are you getting my point? From the minus infinity to plus infinity. Then look at what will happen. You have mod cn square mod phi n square dx from minus infinity to plus infinity. Second term is mod cm square mod phi m square dx minus infinity to plus infinity, and this term will be, you can have, let's say, 2 times real part of cn star cm, and you can just go for pi n star pi m dx minus infinity to plus infinity. What is this particular thing? क्या होगा ये?
One.
Sir, one.
1, because here it is given. What is meaning of that? This is scalar product, isn't it? Unless until you are not going to integrate it, it is not a scalar product. Are you getting my point?
Yes, sir.
Please mind it. Meaning of psi ket psi. This is a scalar product or just a functional product?
Scalar product.
A scalar product. So what is meaning of that? Meaning of that, you have to go for integration psi star psi dx. That will be from minus infinity to plus infinity. So this is your scalar product. Now, if I am talking about psi star psi, what is this particular thing? This is just a function. Are you getting my point?
Yes.
So this value is equal to,
1.
this value is equal to,
1.
1.
this value is equal to
0.
0. Why? Because they are orthonormal basis. They are in the orthonormal basis. Are you getting my point? So never confuse into a scalar product and a functional product. Whenever you are writing the probability density, always take care of this concept. And obviously, again, I am saying mod psi square is not this thing. Okay? This is absolutely wrong. This is just a number, and this is nothing but your mod psi square, isn't it? This is your mod psi square. So your mod psi square is just a function. This is a function, and psi and bracket psi It's just a number. So how your function and number can be equal? But yes, this mod psi square will be become number when we are going to integrate it. And once we are going to integrate it, that is nothing but the scalar product. Hold. Are people happy?
सर
Hmm.
2 into रियल पार्ट सेकेंड फंक्शन का भी लिख सकते हैं ना सी
हाँ, सेकंड का भी लिख सकते, कोई फर्क नहीं पड़ता है. Everyone is comfortable? Okay. So ये चीज आप हमेशा ध्यान में दोगे. So first postulates में आपने क्या क्या सीखा? What you have learned in the first postulates?
Normalization.
First postulates, in the first postulates, what you have learned? You have learned basically there is a Hilbert space associated to your system, isn't it? Unless until you are not going to define your Hilbert space, it is very difficult to define your state, isn't it?
Yes, sir.
है ना? So सबसे पहले आपने क्या सीखा? You have just learned all about the Hilbert space, and that Hilbert space is associated to your system. Your system is the realistic system. Your harmonic oscillator is always harmonic oscillator. You cannot say this is my quantum mechanical harmonic oscillator or classical harmonic oscillator. Harmonic oscillator is a harmonic oscillator. It will depends on you whether you want to approach the classical mechanics or you want to approach to understand this harmonic oscillator with the help of quantum mechanics. So when you want to approach this harmonic oscillator with the help of quantum mechanics, then you have to search for that Hilbert, that function which belongs to Hilbert space associated to the what? This particular harmonic oscillator. Are you getting my point?
Yes,
And
sir.
how you will find this thing, that will be the different issue. But currently at this point of time, if you can able to find the function which belongs to the Hilbert space of this particular harmonic oscillator, your half of the work have been done. Are you getting my point? So first thing, you have to find the suitable function. And obviously, if that function, you search that function must be square integrable. Why that function must be square integrable? Because once the function is square integrable, you can easily normalize it. And once you can easily normalize it, you can use them as a probability density. And what is definition of probability density?
Psi star psi.
Psi star psi is the definition of probability density. Everyone is comfortable?
Yes, sir.
Okay. And once you define probability density, then mod psi square dx will tell you all about what? Which type of thing?
Particle in x scalar and x plus dx.
X plus dx के बीच में होने की particle की probability. What is probability? Such that particle will belongs to x plus dx. Okay. And once you know this thing, you can easily talk about average value of position and average value of position square. That means you can also calculate the error into measurement of x. Okay.
Yes.
है ना? Now we will go for what? Postulates 2. Let's try to go for postulates 2. यहाँ तक clear है? So once you know the postulates 1, that means you define state psi, straightforward. So postulates 1, so this is your postulates 1. So this is your postulates 1. You define psi, you define mod square, and then you can define mod square dx. That's it. This is your first postulates. And this is nothing but what? Probability density, rho x dx. So this is your postulates 1. Okay, this is your postulates one. Now, the second postulates is very, very interesting and very smart postulates. And this will tell you postulates 2. Postulates 2 will tell you the physical measurement of a state. The physical measurement of state psi. So you have postulates 1. In the postulates 1, you define psi, and that is the same psi here. Now my question is that why you are defining the state of a system? क्यों आप state of a system को define करते हो?
So
Can
that
anyone?
every
Huh?
instant system can be known.
Sorry?
How it is. So that every instant we will know about the system, how it is moving and everything.
Okay, obviously you state means that, but इसका फायदा क्या होता है? Once you know the state of a system, आप इसका करते क्या? Suppose classical state, position और momentum बन गया, मिल गया आपको. फिर आप classical mechanics में क्या करते हो? What you will do into classical mechanics? हाँ?
We can calculate
Quantities like
पार्टिकल
energy.
का नेचर जानने के लिए
पार्टिकल का नेचर क्या पार्टिकल का नेचर?
Energy of the particle.
Hamiltonian.
Energy.
Obviously
फिजिकल क्वांटिटीज
physical quantities आप जानना चाहते हो, different physical quantities, isn't it? For example, you want to know what is energy of a particle, isn't it? If you want to know what is angular momentum of a particle, you just want to know what is some another physical quantity, isn't it? So जैसे ही आपको state of a system मिल जाता है, आप पार्टिकल की डिफरेंट फिजिकल क्वांटिटीज जानना चाहते हो. और क्लासिकल मैकेनिक्स में आप देखोगे जितने भी फिजिकल क्वांटिटीज हैं, दे कैन बी इजिली रिटेन इन टर्म ऑफ मोमेंटम एंड पोजीशन. काइनेटिक एनर्जी, पोटेंशियल एनर्जी, काइनेटिक प्लस पोटेंशियल एनर्जी, टोटल एनर्जी, एंगुलर मोमेंटम, all this kind of thing. And once you know how your x is changing with the time, your momentum is changing with the time, you can also say how your energy is changing with the time, whether your system is conserved or not, whether your energy is conserved or not conserved, or any physical quantity is symmetric or non-symmetric. So same thing we have to do in a quantum mechanics too. We have defined any state of a system. It's okay, it's good. But what we will do with this state? इस state का आप करेंगे क्या? Then what we have to do? We have to measure different type of physical quantities. हमें different तरीके के physical quantities को measure करना होगा. तो कैसे measure करेंगे? In a classical mechanics, we have some type of formula and we can use it. But here, Newton's law is not going to govern. So how you will approach this particular question? So why postulates 2 will come into picture. Are you getting my point? समझ में आ गया ना? क्यों postulates 2 की जरूरत है? So anything which can be observed, anything that can be observed, है ना? That is basically physical quantities, है ना? जिसे आप observe कर रहे हो, जिसे आप देख रहे हो. So, suppose any physical quantity, a particular physical quantity, which can be observed, is known as observable. Which can be observed in a lab, okay? Which can be observed. So they are observable. So suppose some observable is some, I am writing this observable in curly A or some artistic A. Okay. You can also just, if you want, you can just make it round. Okay. Some artistic A. जैसे समझने की कोशिश करो, मैं अगर लिखूंगा मोमेंटम, ये तो इंग्लिश में लिखा हुआ है ना, isn't it? Are you getting my point?
Yes, sir.
लेकिन आप इस मोमेंटम को क्या समझते हो? m into v. Are you getting my point? So this is your formula, है ना? Are you getting my point? This is your numerical value. This is just a representation of your momentum. You can represent this momentum with p. ऐसे ही लिखते हैं ना?
Yes, sir.
Okay. So similarly, this is representation of some physical quantity. Let's say energy. को इस तरह से आप लिखोगे. Okay. So this is some representation of physical quantity. So this is not a mathematical thing. This is physical, some physical quantity. So what postulates 2 will tell you? The postulates 2 will tell you. ये समझ में आया ना? ये मैं जो नोटेशन यूज कर रहा हूं. ये क्या है? ये what is this particular thing?
Yes.
There are some
It's
physical
20%.
quantity,
20%.
energy. Are you getting my point? Angular momentum. Some physical quantity को आप रिप्रेजेंट करोगे, कुछ तो लिख कर रिप्रेजेंट करोगे ना, कुछ तो नोटेशन बनाओगे. Are you getting my point?
Yes,
Yes,
sir.
So this is some notation. This one type of notation. ठीक है?
Yes, sir.
Okay. So now, so physical quantity can be observed, which is observable. Okay. Now look at here. There is a operator A. Now this is mathematical quantity. If I am talking about operator, that means I am talking about some mathematical operator is associated to observable, and bracket में लिख लो physical quantity A. Okay, this is that A is observable. So there is operator, और ये operator in general linear operator होंगे. Okay, so there is a operator A is associated to the observable A. So simply आपको आप कुछ इस तरह से देख रहे हो भाई, मोमेंटम के लिए एक ऑपरेटर होगा, एनर्जी के लिए एक ऑपरेटर होगा. आर गेटिंग माय पॉइंट? एंगुलर मोमेंटम के लिए एक अलग ऑपरेटर होगा, पैरिटी के लिए एक अलग ऑपरेटर. वॉट एवर यू वॉन्ट टू डू इन टू द क्वांटम मैकेनिक्स इन अ रियलिस्टिक सेंस, यू नीड सम ऑपरेटर. नॉट ओनली इन द रियलिस्टिक सेंस, इवन अगर आप कुछ एब्स्ट्रैक्टनेस भी कुछ करना चाहते हो तो भी आपको एक ऑपरेटर की जरूरत होगी. Suppose you want, you have, suppose n number of particles, suppose you want to change one particle to the second particle, there is an operator which will exchange one particle to the another particle. Suppose you want to change x to minus x, there is another particle, there is another operator, it is very famously known as parity operator, that will change your x to minus x. If you want to translate particle from x to x plus a, then you have some translation operator. Are you getting my point?
Yes, sir.
कुछ भी आप कर रहे हो, what you need some operator. And so there is a physical, there is an operator A is associated to the observable, and which is nothing but this particular physical quantity. So first thing is there is always an operator, but what is actual postulates? If A is measured on state psi, and this state psi is from the postulates one. You know what is your state of a system. If A is measured on state psi, the measurement of A is eigenvalue of operator A. So what is measurement here? What is
Eigenvalue.
measurement here? A star mark. Make it a star mark. What is measurement here?
Eigenvalue.
Eigenvalue of operator. Whatever be the eigenvalue is coming, that is the measurement. Now, look at to the next part. This is
Sir.
very strong postulates. Very strong postulates. Huh?
Sir, every physical quantity has an operator.
Yes, yes.
और वो
In-
ऑपरेटर किसी और फिजिकल क्वांटिटी पे नहीं जाएगा.
वो ऑपरेटर दूसरे फिजिकल क्वांटिटी को नहीं डिफाइन करेगा.
ओके ओके सर.
ठीक है. हो सकता है कि दो ऑपरेटर मिलकर के एक नया फिजिकल क्वांटिटी बना दे. ठीक है. जैसे मोमेंटम ऑपरेटर और पोजीशन ऑपरेटर मिलकर एंगुलर मोमेंटम बना देंगे. आर गेटिंग माय पॉइंट?
यस सर.
सो हियर वी हैव. बट आपको क्या ध्यान रखना है कि इफ ए इज मेजर्ड ऑन स्टेट साई, व्हाट विल बी मेजरमेंट?
आइगन
Eigenvalues. If A is measured on a state psi, the measurement is eigenvalues.
Something like characteristic equation.
Obviously, you have to go for to solving the characteristic equation. Then only you can find the eigenvalue, isn't it?
Yes, sir.
Okay.
Sir, how that eigenvalue is related to our physical quantity?
This is
How
postulates. This is postulates. You have to just believe on it. Are you getting my point?
Yes.
This is just a postulates. In the postulates, you cannot raise the question how it is going to happen. You have to just believe it and just want to apply on your system. If this assumption is correct, then it will give you the correct answer. Are you getting my point?
Yes.
है ना? Now, so you have A phi n is equal to an phi n. A phi n is equal to an phi n. And what is this an?
Eigenvalue.
Eigenvalue.
of
And what is this phi n?
Eigenstate.
Eigenstate. So इसको आप क्या कहोगे?
Eigenstate.
Eigenstate. ठीक है? So the second postulates can be written as A phi n is equal to an phi n. So this will be just tell you eigenvalue and eigenstate. Okay. So here an is eigenvalues. And this is measurement actually. An is eigenvalues and corresponding eigenvector is phi n, which is identified as eigenstate. Which is identified as what? Eigenstate. Please, फर्स्ट में हमने क्या सीखा था? ओनली स्टेट. सेकंड में क्या देख रहे हैं? Eigenvalue and eigenstate. Okay. Now, next is, now just tell me, your physical quantity must be real quantity or some imaginary quantity?
Real quantity.
They should be what? Some real quantity.
Real.
So, hence, an must be real. क्यों? Because an is your measurement, है ना? What is your measurement? Measurement is nothing but the eigenvalue. So measurement
Yes, sir.
must be always a real quantity. है ना?
Sir, an is measurement of that physical quantity, na, with which the A operator is associated.
Exactly. Measurement of any physical quantity. Any physical quantity must be real. है ना? मोमेंटम तो हमेशा रियल ही होगा ना, चाहे आप क्लासिकल देखो या क्वांटम मैकेनिकल देखो. इमेजिनरी मोमेंटम का कोई मतलब नहीं है. आर गेटिंग माय पॉइंट? So hence an must be real because physical quantities are real. So an must be real, which ensure A operator must be Hermitian. समझ रहे हो ना? Hermitian matrix के आइगन वैल्यूज हमेशा क्या होते हैं? That will be always real. So you have always A dagger is equal to A. A dagger की वैल्यू हमेशा क्या होगी? A के बराबर हो. इसका मतलब क्या है? A को आप किट पर ऑपरेट करो या ब्रा पर ऑपरेट करो, व्हाट यू विल गेट? यू विल गेट एग्जैक्टली सेम थिंग. है ना? Because your eigenvalue is what? Real quantity. And now last is very important. देखो ये सारा हम पढ़ चुके हैं, पहले पढ़ चुके हैं ना, इसी कारण आपको अभी समझने में आसानी हो रही है. नाउ द आइगन स्टेट phi n corresponds to physical corresponds to operator A must be orthonormal such that it can make complete basis. याद है completeness relation?
Yes, sir.
Complete basis. That means your phi n must be equal to what? I. इसका फायदा क्या होगा? इसका फायदा ये होगा कि यू हैव एनी स्टेट, कोई भी स्टेट है, और इस स्टेट को आप किसके बेसिस में लिख सकते हो? आइगन स्टेट के बेसिस में लिख सकते हैं, है ना? एंड दिस कैन बी रिटन एज phi n psi. So any state can be written in a basis of eigenstate. This is the actual thing in a quantum mechanics. This is the most important thing into quantum mechanics. So you have make your formulation of quantum mechanics so beautifully that you can reach the realistic measurement of a system. Now look at, everything is very abstract. Everything is very abstract. But what we are going to do? We can use this abstractness to figure out the realistic measurement. This is beauty of quantum mechanics. Everyone is comfortable right now? अभी खत्म नहीं हुआ है, थोड़ा सा और है ना? So what is idea? What is idea? The idea is that you have some state, you have some operator. You can easily find the eigenvalue and the eigenvector of that operator. Eigenvalue is the measurement. And what you can do, you can write this state psi in a basis of eigenstate. Are you getting my point? Suppose कोई psi दिया हुआ है, and if you want to measure the momentum, then what you will do?
Momentum operator.
Obviously, you have to define one momentum operator. Yes. And once you define momentum operator, you will find the eigenvalue of the momentum operator and the eigenstate of the momentum operator.
Yes,
Anna?
sir.
Yes. And now what you will do? You will just write your psi in a basis of eigenstate of momentum operator. Isn't it?
Yes.
अब सपोज करो आपको एनर्जी निकालना है, तो अब आप क्या ढूंढोगे?
Energy operator.
Energy operator. And once you find the energy operator, you can find the eigenvalue and the eigenstate of the energy operator.
Yes.
और अब psi को किसके बेसिस में लिखोगे?
Eigenstate.
Eigenstate of energy operator.
Energy operator.
Are you getting my point? Suppose you want to measure angular momentum. What you will do first?
Angular momentum operator.
Angular momentum operator, and then you will find the eigenvalue and the eigenvector of the angular momentum operator. Yes?
Yes, sir.
And then you will write the same psi in a basis of what?
Angular momentum eigenstate.
In the basis of orthonormal basis of angular momentum eigenstate. So आप जिसमें भी मेजर करना चाहते हो, जिस भी क्वांटिटी में मेजर करना चाहते हो, आप क्या करोगे? पूरी की पूरी स्टेट को उनकी आइगन स्टेट के बेसिस में लिखोगे. ठीक है ना? So any state can be written in a basis of eigen state of operator, or in a orthonormal basis of in a orthonormal basis of eigen state of operator A. So you can easily write your psi can be Cn pi n. And what is your Cn? Where Cn is equal to pi n psi. Isn't it? This is very strong postulates. Now the question is, now the last but not the least, every eigen state can be treated as state of a system, but it is not necessary that every state is eigenstate. Okay? It is not necessary. Every eigenstate can be treated as a state of a system, but every state or cannot be eigenstate. It may be, it may not be. Depends on situation. So this is your postulates 2 and 1. So we will take a small break and then we will discuss a lot more about the postulates 2 and then we will go for postulates 3 also. Okay? So take a break. In that particular 5-minute break, you can just revise this postulates 2 properly. And then first you can ask me a little bit of doubt from your copy only, at which line you are not going to understand. So I'm just giving you 5 minutes. Take your time to just read all this thing, whatever we have written into the postulates 2. And after then you can raise the doubt and we will just try to solve one very simple problem such that that doubt can be removed, and then we will go for postulates 3. Why? Because postulates 1, postulates 2, and postulates 3 are always simultaneously written, or you have to learn it simultaneously. You have to read it simultaneously. Okay, so take a break, and after that we will again come. Okay.